Welcome back, Reg audience. We're here today to get you out of your network rut. We assume that you are in one, or else you're on the wrong Regcast. Don't go anywhere. The idea is that from our Regcast, as you will see, the data center that you've ended up with isn't really the one you wanted. You haven't done anything wrong. It's just the world's moved around you. So how do you adjust to that? We know quite a lot about the way in which you prefer to upgrade, you prefer to spend your limited IT budgets, and unfortunately it means that the solution to getting out of your network rut isn't always the easiest thing to do. So we've given an hour to try and get some progress to work it out. Let's hope we can do that. Who's going to help us do that, you are asking me? Well, I will tell you. So we've got two guys from Brocade in today. Marcus, welcome.
Thank you.
To our studio. Yes, you're a VP at Brocade, so it's good that we've gone right to the top. We've got the main guy.
Well, I don't know about that, yes.
There's nothing you don't know about this.
Well, we'll see after this hour's finished.
Ask anything you want to Marcus. There is nothing he doesn't know about.
Yeah, anything that's an SEC regulation, clearly I can't answer on this call, so I made that point before.
With one bound, he was free. Welcome to the studio. Julian, what's an SE manager?
Myself and my team, Tim, look after our enterprise customers in the UK, so we have a pre-sales function.
I see. So your enterprise customers, are they in a network rut at the moment?
Many of them are.
Yeah.
We've helped many also.
Yes. And do you when you're talking to them, do they tend to present you with the same problems? You know, is there a pretty big consistency about what's happening here?
There are, and many of them find, certainly when we talk to those who have spent a long time and are on a journey of implementing virtualization, storage consolidation, just simply find that they're having issues with the network, which I'm sure will come on.
Good. So I want lots of stuff from experience from you today. I want you to tell us how it is. Now, also, back again, Dr. Stats, you're back in the studio.
As always, Tim, you can't keep me away.
We can't keep you away. We've tried more or less everything, but, you still come back.
You can't lock me out with a name like mine.
Yeah, you can't really. Now, we're doing a lot of things. The reason why you're always in at the moment is we're doing quite a few things that you like. These are topics that you've got an interest in. Indeed.
It's about making things work and getting services out to people.
Yeah, and I'm not saying you're a sort of a weird person, but I mean, not everyone is motivated by data center networks, but it is important.
It's the invisible importance that's really interesting here.
Yes. Good. So we will, as you know, I'm Tim Phillips. Now, we will get into this. We can get quite technical if you want us to. Just ask. Which brings me to how you use the interface that we've got today. For those of you who've been on a Regcast before, you will know that the buttons above our head will help you to get the most out of our Regcast. The most important one is to ask questions and tell us what you are worried about. And if we touch on something and we don't explain it properly, then tell us in the questions and we will explain it further for you if we can. So please do that. You can also get the slides on a download. You can also look at the links that we've got at the end. We've got quite a few links today, so you can also get access to those. And let us know how we did afterwards. Most important thing, ask the questions. Ask the questions. They come in here, and I ask them to those guys. So let's start, Tony.
Yep.
Data center networks. Why are we in a rut? What's the rut that we're in?
The rut that we're in is pretty much the same as in most parts of the data center. It's because essentially today's data center hasn't been programmed and built from the ground up. It's grown over time. And in particular, the networks that keep data centers working have quite often elements of them have been there for years and years and years, maybe even older than a lot of the servers and storage sitting behind them, because you've plugged in the network essentially to meet a single business requirement, and that's been it. It's been fixed. That's the way we did things in the past. Mm-hmm. And this invisible sort of glue has just grown up silo by silo, being managed very statically, because again, that's the way networking worked. You put it in, you left it alone, you only touched it if you had to. But that's sort of grown there. Now, we might have added in a piece here, added in an extra router there, put in some more backbone, whatever. But again, we haven't changed everything all at once. It's been there, it's grown over time, it's just evolved almost, and literally evolved almost in the Darwinian sense that, we've done lots of things, some of which have been really good, they've grown, but a lot of the other stuff has just kept on living.
So the various data centres around Europe that literally have your fingerprints over the network.
Not quite mine personally, but it's certainly the way that they've grown up
for you. And that's it. Sorry, guys. Do you see this? Where you see these data centres that have been built and large areas of the networking just untouched?
Yeah, for sure. I mean, so the networking market is dominated by a very successful company, and so it's kind of been an add-on and a scale out over a number of years. A lot of people on this might not think they actually have a data center or don't think data centers are relevant. Well, a computer room's a data center. We've just changed the nomenclature of that over the last couple of years. And the problem is that what they were designed to do is not what we're asking of them now in simple terms. They were designed to support, in simple terms, a client-server architecture where you had applications running on a server, you had users accessing those applications, and we're now in a virtual world, whether it's virtualization with VMware, virtualization at the endpoints. So what we're actually asking the data centers to do is move traffic in very different ways, very unpredictable ways. And so we have a hierarchical network, we call it, which isn't really suitable for the modern traffic flows that we see.
Yeah. We've got very inflexible environments that have been okay for yesterday and to a degree today, but the audience knows that going forwards to tomorrow, they're not really going to work. And they've been very labour intensive to actually manage them, which is why they've been left alone.
Yeah, they stayed the same for good reasons, though, Julian, didn't they? Once you've got something working that's as complex as this.
That's very true, and we still see projects today whereby people are building physical buildings. They're kitting them out as a data center, putting in infrastructure, and the first thing that goes in is the cabling and the network. Mm-hmm. Quite often they're then constrained when they put in virtual server infrastructure. Often now with integrated stacks where people are bringing in almost a top-to-bottom infrastructure, wheeling it in, plugging it into the power, plugging it into the network, to find that it's not necessarily a problem when you put in the first one, but when the second one is in the next row or the next tech hall or perhaps the next data center, and you want all of those to exist on one piece of wire, that it's just not suited.
Yeah.
They've been very technical, and we also haven't put a lot of visibility onto the network. When networking first came into the business in the client-server era, there was a lot of attention paid to it, but then it sort of worked for the next 15, 20 years, and it's only really becoming visible again now because a lot of the issues that Julian just said, we're trying to do more things with it, and that expectation to do new things is really important.
I think another point is you just can't turn it off. It's one of those systems which can be turned off and migrated. It's inherent to the building infrastructure, it's inherent to your applications. We're in an always-on culture, so turning a network off isn't really an option for the majority of people. We have to scale out. Scale out means you tend to do what you did before because it works. Mm-hmm. So no one's suggesting the networks don't work. They just don't work particularly efficiently, or as efficiently as they could with the modern technologies.
Yeah. Tony, what's the Reg audience saying about our limited ability?
Well, top of the list in terms of how people have impacts on their network is literally the human skills to do it. Mm-hmm. It is, as we said, it's been complicated.
Is it not enough people, or they don't know enough about the network?
To a degree, that varies on your organisation. Really big data centres, they've got network specialists, but usually they're asked to do too much, the same as everybody else in the data centre. Yeah. As you move down into mid-sized businesses and smaller, networking is just simply part of everything else that the guys there have to do. And so you know enough of it to get by on. Mm-hmm. And that skill side is really important because networking has traditionally been really difficult to do. You've got to know a lot of stuff to make it work both effectively and securely and reliably. Mm-hmm. And so that skills, the management tools layered on top of that, because again, in the past, these were static environments, and so therefore the management tools were basically around, get it working, leave it alone, only change it if you have to.
Just to monitor something that's already been set up. And
they didn't even usually monitor too much. They just existed to manage rather than monitor. The monitoring of the network is something else that we haven't really done a lot of until people start getting bottlenecks, which with some of the new services that are coming along might impact that. So visibility and understanding of what's going on, who's using it, where is the traffic going today. As Marcus and Julian both said, there's a lot more east-west traffic now between computers rather than from the user down into the infrastructure. So there's it's a very different traffic flows inside that network that many people haven't got visibility of directly, but they feel the consequences of in terms of service performance.
Mm-hmm. It becomes an under-resourcing problem, doesn't it?
What I find interesting with this statistic is the second most important factor there seems to be lack of capacity planning. and in terms of impact. And as I'm meeting with various people from different infrastructure teams with my customers, I find there's been somewhat of a renaissance with capacity planning as people have virtualized and pooled infrastructure. And I find myself talking to many more capacity planners, and they're attending more meetings as we meet with teams. But they tend not to look at the network in the same way, because they're either from different teams or they don't have those skills.
I see, right. Yes, we do have these problems. We're going to get onto teams, aren't we?
We are indeed.
We're just going to reference that. So what we end up with, Tony, here is in your the sort of Dad's Army slide here, all the different arrows.
That does take me back.
it somewhat dates
to
me
when they
well.
were first broadcast, yes.
Yeah,
not just the repeats.
You've got the you have all these things pushing in on the people whose job it is to modernise the network.
We've already talked slightly about the user expectation.
Yeah.
The new services side. There are these new things coming along, whether it's VoIP in the network, whether it's video, whether it's a whole bunch of different services linking with partners more and more. But that user expectation side is something that's maybe under-recognised. Because when I first was working in computer systems, people sort of expected that there'd be failures now and then. And as an IT infrastructure guy, my first response was always blame the network. Even before I'd looked at any monitoring tools to see what the problem was, just blame the network. But now people think that the network should be there all the time. And more importantly, they don't think about the network at all. They want the service to be there all the time. And without the network, it doesn't matter how well everything else is working. So that user expectation side is really important. The business demands, well, we all know that people want things faster, quicker. Performance, equally, we want better response times. The whole virtualization side has been touched on. It's something that we'll come back to time and again. And underlying networking, almost subconsciously, is the elements of security, to make sure that only the right people can see the right things and the right services are accessing the right data.
Is this different? We've always needed all of this.
I think what's really different is the executive community now are much more IT aware. You've got to remember that the CEOs of companies, CFOs of companies now can be in their mid-30s, even in public businesses. So they've grown up with a networking environment. And everyone, to a certain extent, is a networking expert. If you've got a tablet, if you've got a smartphone, at some point you'll have figured out how to connect to something. So this puts different pressures onto the business. And the other thing that's happening is applications becoming more aware, and they're coming more to the executive level. If you go back 10 years ago, an SAP implementation, I'd challenge to say, the C-levels really didn't look at it. These days, you go to a CEO, he'll have a dashboard of his ERP system. He will know what's going on. He will know the puts and takes around this. Because IT is now in the boardroom. 10, 15 years ago, it really wasn't. We used to work with companies where email was banned, yeah? And then all of a sudden they realised what email could do, and then all of a sudden, everyone had it. So those changes, I think, put a different focus down, and what's moved on is the expectation, but the underlying infrastructure, the rules of that infrastructure really were set back in the mid-80s. By the IEEE or Xerox DECT and the people that set the Ethernet standards, and we haven't really moved on from that. That's what's holding us back.
Okay.
I think what I take from this, Tim, is that those new services, that the innovation that we see in other parts of the infrastructure has simply outpaced the network, and I think that point's already been made clearly. But to underline that, I have customers at the moment who are working on active data center initiatives. They're using the virtualization capabilities within the server layer and advances within the storage infrastructure to be able to run workloads where they want them to work and to move them seamlessly from one location to another, which adds tremendous value. However, within those same customers, I'm attending meetings with the network team because they're trying to work out how to seamlessly connect the network between those data centers and overcome those problems. So on the one side, there's been a significant investment made in parts of the infrastructure which has the promise of delivering great value, and it's inhibited by the network. So instead of being an enabling function, that yellow line across the previous slide, it's now an inhibitor.
And that's something that has come out time after time when we've carried out surveys across the board with whichever area of the infrastructure we've been looking at, whether it was the server virtualization side, the storage virtualization, the increased use of desktop virtualization. Quite often, one of the inhibiting factors that everybody who started down the path has come across that they hadn't expected to hit was, how can the network deal with this? We can get it up and working statically, but the ability to change things quickly hasn't been there.
As you're talking about here.
And that's what comes out here.
Yeah.
Flexibility is the really key thing here. And underlying that to a degree is the requirement for management tools that can actually help you automate a lot of the processes. You know, there are things in networking, the same as in any other part of the infrastructure, that you do time after time after time. And as we all know, that people changing things quite often is the cause or the initiator of a service interruption. You know, it's not a hardware failure, despite some surveys saying that hardware failures are the biggest problem. They're not. It's people changing things that break service delivery. So that flexibility, the need to automate as much as we can so that people can just keep on working productively for the company, are all in there, which underlying that means if you want to automate things, you need some sort of policy, but what policies do we need wrapped around the network? And then do we actually need to change some of the processes, the operational processes we've got at the moment, where in the large data centers we've probably got a number of siloed teams that only talk to the networking guys when they have to, whereas now they're going to have to be talking to them potentially all the time unless we can get more of that integration going on at a team level. But one really interesting element here is change management, because as we said, change can introduce, you know, risk to service not being available. How can we get change management that can work as quickly now as, you know, the whole IT infrastructure potentially could?
I think there's another point to add as well, that networking is no longer a separate physical asset. So as soon as you virtualize at the server level, then obviously switching between those virtual machines could be within the same compute stack. And therefore that's all happening in software in the backplane of the actual server architecture. So networking by its very nature is already becoming abstracted from the physical infrastructure. And that leads on to network function virtualization and software-defined networking, which I know we're covering later.
Yes, we are. We will go into SDN in quite a lot more detail later, you know, given time, so we better make sure that we do leave time for it. And
it does raise the need for better monitoring of the network as well, so that we can work out where are there any bottlenecks that we need to get around, because we haven't monitored networks terribly effectively. That's got to change.
And there are two paradigms I see here in the industry. The first being, I will build the network and I will configure it. So I'll build it and they'll come if you like. I'll build it and I will allow people to consume the services that I configure, which is a very old way of looking at it, but one that's still present. The second is to say that the network must adapt to what's deployed around the edge of it, so intelligence, as it were, so that I no longer interact with the network in the same way and use what it offers. I deploy services that the network
I do stuff and I expect to get the service that I've been promised or that I want from that, which is a very different functional way of working.
It's a different way. It's much more the service-oriented approach that we know from a survey we carried out with the Reg audience at the beginning of this year, that everybody thinks is a really good idea to move towards, but we're not sure of the steps we need to take there. And one of those big underlying, how do we get there, is really sort of summed up in this next chart. The survey that I'm just talking about, we categorised people into those that have already moved, so that the really advanced people that have had time and business needs to move forwards. Everyone else who would like to move forward but not quite sure how to get there, down to the traditionalists. And one thing we found that was common to all of them is that the idea of rip and replace in any part of IT has never been a flyer. And that, you know,
rip and replace is the black.
The black on the left-hand side, people don't do that. And that applies, you know, in spades almost to the network, because the network has been, you know, it is so critical that if you get changes to it wrong, you can't take the risk of taking out everything, never mind if you can afford it. You need to grow this and evolve it and change slowly, and that's the way networks have done. So how can we get that best practice to move forwards without locking ourselves in? Because that's the key to this, you know, how to change without, you know, risking what we're doing now, but giving us the flexibility to move forwards tomorrow.
So the problem we've got, if I get this straight, is on the one hand, it would be very convenient to be able to rip stuff out and replace it with the stuff we know. On the other hand, people don't want to work like that, and B, they've got no...
You can't afford to do that.
You can't do it, because you can't say to people, network's off, be back again in a week's time when we've plugged everything back in.
I think there's also, you know, some of the assets that are there are fine and will be fine for another long kind of period. So Particularly if you look at core routing solutions, which are in the middle of most networks, most of those are adequate for the next cycle. Routing isn't really going to change fundamentally. We're limited by the number of VLANs that can be run in the 4,000 range. Nothing's going to change that within the IP stack. So core routing solutions, you could argue, actually could be sweated for a longer period of time. There's some of this aggregation layer and some of this data center layer which is really the inhibitor in most organizations.
And
that's the important thing, know what you can do. Don't try and boil the ocean. Find the bits that really give you big benefits now, put them in, but put in a platform so that you can expand from it to do more as the requirements meet your needs.
Which is
the yellow bars.
That's the big yellow bars on that. So what we're saying is across the board, people are doing bits, but more if you're a mover, but it's still
work out where you're going to get the benefits now so that you can show them and you can afford them, but put in something that lets you grow going forwards.
Your mission, if you choose to accept it in the next 40 minutes, is to work out what those bits are.
Yes, well, they're complicated, and the key is just taking steps and making sure that you can integrate what you have. So I think anyone that's in the market saying software-defined networking or their architecture is a rip and replace is going to get it fundamentally wrong. You have to evolve. And you have to evolve with low risk. And also, there's a condition. People are conditioned to buying things, actually, in a very specific way. And what they require and their buying behaviours don't actually change challenges quick enough. I mean, a lot of the buyers out there may disagree with me later. But, they say that, we're coming up to a slide in a minute which talks about reducing complexity and all of these kind of areas, looking for, exactly this slide here, telling the people what they need to do. And the reality is they still purchase things in the way of the old schooling, or how many VLANs to support, what's the routing backplane speed, what's the MTBF between. These things are becoming less and less relevant.
What are you saying they should be asking?
They should be asking these questions: is how does this tie to the eliminating complexity, reducing cost, and then also augmenting a solution which automates the process a lot more? These are the questions they should really be asked. And I guess it's the vendor's job, probably the press's job to a certain extent, to help educate and push that message out of tying these business benefits back to some of the discrete functions that you have. The analogy that we use is, we talked about it outside. When you buy power provision for a building, do you go to the power provider and ask them, what equipment are you using in your plant? What's your transmission method? What are you using in your substations? Who manufactures your equipment? What's the throughput? You don't care. You're looking at a tariff, a service level agreement, and maybe some other conditions. That's ultimately where networking has to go.
But it does raise a really interesting point, and that's that the register audience have told us that the bulk of networking spend is as an infrastructure cost element, and that's really difficult to get hold of in these times when you've got to tie that intimately back into some immediate business benefit. Usually some project that's going ahead that you can almost piggyback off of. So that's an important element to try and tie the business benefit.
The central pot of money comes out of that.
Networks are funded centrally, but how can you therefore get extra funding to do new things in a way that the business is willing to say, I see the benefit of that, so we're willing to pay for it.
Do you not also find, Tony, that there are specific requests coming from other parts of the infrastructure team, so from the server teams who we find today wield quite a lot of power to some degree, there, and that they're asking for capacity upgrades. They're asking for the network topology to look different. They're asking for connectivity requirements that don't necessarily exist.
Absolutely, but again, those guys have got the same problem that they've usually got a business pressure coming in that means they need to do something new. So it's very intimately tied into it. But then getting that translated down to then how can we spend on the network and get that allocated into the budget as well, because getting an extra network infrastructure budget, as a line item for the year can be tricky on its own unless you've got that context to put it in so that people can make a business case for the investment.
We're moving from discrete systems. This is the problem. The network was discrete, compute was discrete, storage was discrete, end user devices were discrete. They're no longer, the network equally resides with the storage team, with the server team, with the networking team. Interesting, VMware at VMworld were talking about how they're going to approach their move, the acquisition of Nicira, moving into software-defined networking. They're actually bringing in an overlay team to talk to networking teams about this because they realise that the server teams don't have that budget and that power. So, ultimately it'll be like unified comms. We went through a TDM PBX market, which has turned to an IP telephony voice over IP market, and now those decisions are fundamentally made by the IP networking team or the
I hope it goes
teams.
more smoothly.
Well, there was too many false dawns. The reason, and I was in that world for a long time, was that actually the product wasn't good enough in the early days. That was the reason. The TDM system was actually, and that might be controversial as well, we're going off track here, but with where we are now, the advantages are so big with virtualization, the cost savings are so massive that there's almost just a rush to virtualize whatever you can. We're also in a little bit of, and I don't know if Tony has a view on this as well, we're also in a kind of an exponential bubble of virtualizing everything, and I think it will settle, and people will realise that not everything should or could be virtualised, and it will settle down after time.
The Edge audience have told us that already, but the really interesting point that you raise is the way IT is financed, and it's something that we've come back to time after time. Yeah. It really does need to change, and the network potentially could benefit from that, but most organisations haven't reached that tipping point where they've worked that out and that they need to do things differently.
So what are we actually saying that they can do to get that as a line item on their budget? What do you actually say to someone?
It's going to come down to, well, what new business elements does this help you to deliver? And that's going to be, it needs some planning, it needs some time and thought, but it does mean taking the network benefits and turning them into something that the people approving budgets can actually agree with and recognise.
But as we were saying, we're in this shared infrastructure world now, and so that will be
needs different way to pay for.
When we do surveys, one of the most important feedbacks we get is that the biggest thing about cloud, and I'm glad we've spoken for 23 minutes, and we've only just brought up the word cloud.
And you did it.
I did it. I do apologise for that. Yeah. But the cloud technologies, the most important thing is the business model, because it moves CapEx to an OpEx, and it gives you flexibility to scale up and, more importantly, scale down. So, and human nature is, you like to be into something. If I've got this wrong, the capacity wrong, and I've got too much, can I get money back? CFOs kind of particularly like that. We actually went to market. We have a subscription service. So we offer, you can buy our hardware as a subscription with no minimum term. And people are doing it because it actually opens up a different way of getting to these benefits that you have. And we think we'll see that become more prevalent.
It works for service providers, but it's really difficult for enterprises because they tend still to have fixed pools of money for the year, so they've got fixed budgets. So things need to change, but people aren't quite sure how to change them.
So it's a good question saying, are we going to discuss software-defined network? We are. SDN will be in. It's discussed. We're kind of getting there very soon, actually. So hold on for that. But it underlies all of this, because at the moment we're talking very much about people's problems. Yes. And there'll be a few of you who'll be saying, "Yeah, I know I've got this problem," and it's true. We're just pulling it apart so that when we tell you how to solve your problem, then this is why it's relevant. Now, tell us about this. The constraints. The network turns out to be a constraint now, where it never used to be.
Yeah, so we go back to first principles. The reason that networking exists as a separate hardware solution was because at the time the microprocessing or the CPU and the memory costs were not available in standard technology to run networking as an application. Networking has always been an application which runs in discrete hardware, as much as telephony was always an application which ran in discrete hardware. What's happening now is the big paradigm shift for us is that memory costs are kind of dropping very, very quickly, even quicker than Moore's law would suggest. And actually the compute power from Intel is such that, it's kind of at an equivalency to some of the merchant silicon providers like Broadcom. So now actually you can put network solutions into standard x86 infrastructure. And the first thing to try and define here, this is what we term as network function virtualization. This is not software-defined networking. Many people are confusing these things.
Oh, yeah, I am confused. No.
So what we can do is, let's take an example. We have a product called a Viata router. So what that is an enterprise-class router. It's a full throughput 10 gigabit per second router. It can do, most of the routing protocol that maybe a 2,000 to 3,000 edge device could do from one of our main competitors, which is a hardware product. That's £50 as opposed to £2,000 to £3,000. And they're being deployed in great scale. Amazon Web Service, for instance, do all their routing on the Viata router service because they don't want to deploy hundreds or thousands of these physical boxes. The advantage is the same old thing: reduce complexity, cost, speed of deployment, the whole thing, power, cooling, everything. And so certain networking functions can now be virtualized, certain can't. High-end routing, where you have a lot of throughput, really you have to have merchant or actually bespoke ASICs to do that. And you'll see that change. Ultimately, we could be in a position where you don't need any specific hardware to run to run networking. That's probably 20, 30 years away, but that ultimately could be the goal. That's network function virtualization, not software-defined networking.
Okay, but so we're saying network function virtualization is something not to think about now?
So, to think about, yeah. I mean, absolutely. Think about now. Why do you think you need a specific piece of hardware? Is there a piece of software that can do the job? Do you have capacity in your virtual server environment, your compute environment with your stacks to put these products in? Most people have capacity still in their server environment, and so...
Yeah. The interesting question comes, what do you not know about your environment? So something we've touched on time after time. What are you monitoring? Do you know where the bottlenecks are?
Yeah.
So that you can make logical decisions. And finding the time to do that sort of work can be tricky.
Yes. Yeah.
And speed of deployment is an important consideration. And when you consume web services, when you consume infrastructure as a service, and you choose to pay by credit card or however that transaction happens, and that infrastructure is handed to you almost immediately, that work order that's issued doesn't then force somebody to go and implement some hardware, a load balancer, a firewall, a router. That needs to happen automatically and very, very quickly, but from a multi-tenanted aspect as well. Mm-hmm. And that impact applies to the enterprise as well, and not just the cloud service providers.
That's the day where you fill up a shopping trolley and take it off down to the data center and plug some stuff in. Can't do that.
Absolutely. Time.
There are some other conditions as well as the demands on the network, we keep forgetting, continue to increase. Yeah. I mean, we cannot manufacture 100 gigabit ports quick enough. This is a real shock to us. So we actually have kind of an 8 to 9 month delay because it just takes so long to manufacture. They're very expensive. I mean, they're $100,000 a port, so it's not cheap. It's mainly a service provider specific product. But what we're seeing is that the demands between storage increase, speed increase is such that the network function virtualizations really get started at the edge of the network and moving back towards the core. Core networking still really does require this ASIC delivered hardware. And
the amount of data that people are generating, the apps that they use are just bigger. That they've pushed more data around, and people just accept it. Everybody runs video all over the place now. Whether they're streaming it in from outside to watch the football at work, or whether they're running corporate training schemes, it consumes a lot of bandwidth, and it takes a lot of effort to move it around. Data's heavy.
Good stuff. In the second half, I'd like to take this down into steps that people are actually going to take now. So so that we've. Let's try and sort out some of the problems. So, this is one of the reasons why it's going to matter. This is something that's going to be that people in the audience will say, yeah, this is my life. This is the complaint that I'm getting now.
Yeah. So I mean, it's kind of moving away from the self-healing and automated nature is what people really want to address here. And at the moment, networks will fail, and networks fail normally because somebody's changed something, and that can be an internal change or an external change. With information flows have changed, somebody's made a routing change, somebody's made a physical change. That's normally the consequence. Hardware is pretty robust these days. Mm-hmm. The only problem you do get with products is software, and I determine that software is human intervention as well, because a bug is actually a piece of code written by somebody.
It's a human intervention somewhere.
It happened years ago, in a development lab. But those are really the problems that we now get. So, we just need to move into abstraction to allow these networks to perform at their best, and having these orchestration and control layers somewhere else. And I think that's the point we're going to get to quite soon.
So what do you do then to move in that direction? Here's my question: if I wanted to take my first step on that.
Your first step really is to look at what applications you're trying to run. A network is only there to run an application. So the first thing is access the applications and access the connectivity types that you need, and that's not a particularly difficult piece of work to do.
Asset management. We come back to it time after time after time, and it's not always me that brings it up first.
Yeah, absolutely. The next thing, once you figure that out, is to then look at the most efficient way of delivering that infrastructure, and that comes down to cost and complexity. And then to be brave and look at some of the newer technologies. We're going to come on to Fabric Ethernet, which is pretty much the standard which everyone is saying. Brocade say it, Juniper say it, Cisco say it. That is the way to build a data center on a fabric. Now that looks very much like a fiber channel network, which obviously we're the dominant player in the market for. And so making those steps to enable you to have self-healing, multi-tiered, getting away from multi-tiered networks, allows you to move into this automation piece. If you try and do the automation and control and get into these savings with what we call the hierarchical networks, which are designed for client server, I don't think you'll ever get there. It's like a journey with your children in the back of the car. Are we there yet? Are we there yet? Are we there yet? So we think we need a physical infrastructure change of attitude in order to deliver some of the software-defined and orchestration benefits that you're going to get.
But your research that you brought in here, sort of, Julian, is basically saying that a large amount of money at the moment is just keeping the thing going.
Keeping the lights on.
Yeah.
In essence.
So we're basically saying divert money away from that, if you can, whenever you can.
If you can, but those... And this is, as Mark has said, this is about starting to add incremental capability within those. So as we talked about, we go back to finance again, and some of those projects that you put in, that when certain requirements are requested of the network, that you think about taking some of those small steps, putting in a small amount of automation, putting in a small amount of intelligence that starts to bring down complexity, that starts to reduce time to deliver those services. And as you start to introduce automation and reduce complexity, reduce the configuration overhead, that 71% comes down, and that saves you money elsewhere, which means that on your next project you can do the same thing and take those steps again.
Our heritage of being a fibre channel company or a SAN organisation, we've only ever existed in the data centre, so our credentials in the data centre, in my view, are sky high. If we compare how many people it takes to run a 4,000 port fibre channel network compared to how many people it costs to run a 4,000 port IP network, it's a factor of probably 4 to 5 different. You can have 3 maybe people running a fibre channel storage network. The IP team will be way, way bigger. Now, there is more complexity. There is more moves, as and changes. There are more dynamicism to that network. But clearly, there's a paradigm here which isn't quite correct. There should be more efficiency that we can drive by using some of the conditions that you see in the storage area network and overlaying them into what we call the data center, new data center world. We think will drive those efficiencies and reduce those people.
You've got expertise already internally. Just to add some particular goal to your project on that, to have the team looking at that all the time.
The threatening thing for us, the biggest uptake of our product solutions, our IP product solutions, is from the outsource organisations, maybe the subcontinent, the Indian outsource organisations. They're taking our products to market in anger. And that's a threat, because actually they're a competitor potentially to all the internal IT departments, because you can have a board going, how come, Wipro or TCS can do this way, way cheaper than you can? Because they're taking a different approach. They're not trying to create hierarchical legacy network. They're trying to create a much flatter, automated and orchestration network.
Mm-hmm. But they're starting off usually from greenfield sites, so it's a question of how you can get there. The other thing to mention about that overhead slide is that not all overhead is bad, but the idea is to minimise it, because you're always going to have overhead. That's a matter of life. Keeping the lights on is no bad thing if you want to read a book, or if that's where all your money's coming from. So it's just a matter of optimisation.
Well, the concept is taking those heads to be more business aligned, to actually driving the revenue and the cost reduction of the business, as opposed to just keeping the lights on. No one's saying we're going to reduce the number of engineers. That's not the point. It's about increasing them to allow them to do more.
And the acceptance of automation has also reached a stage in most areas of the infrastructure now where the IT guys get it and understand that there are some things that we really can automate. The tools have caught up with the promise. Now we've got to get that same feeling of comfort in the networking side.
Build that in. Except this, this idea comes into your sort of productivity idea here. It's a different aspect of the same problem, really. Here, isn't it? That people.
It's the flip side of the coin. It is all about productivity gain. The only two reasons for a network is to support an application and connect people together. The only two reasons a network exists. So it has to be as productive as it possibly can.
Yes. Okay. So what I'm going to skip around to this part of it, deployment delays and provisioning time. We've already mentioned that. What can we do about time to deploy?
This, to me, is abstraction. I'll hand this over to Julian, who will speak far more eloquently on this. But this is about, introducing that abstraction layer to the network. Instead of physically getting down to, even the base CLI levels and actually have to do some programming, consider about VLAN changes, worry about, am I going to get bottlenecks in the network? And, and every time you touch something physical, there is a chance that it can go wrong. It's much better to have that abstracted in some kind of virtual environment. And I'll let Julian.
How do you do that then, Julian? You're on.
I'd like to start with thinking about services creation. We've got the services coloured donut, as you like to call them.
Our multicoloured donuts, yes. The services one on the right.
On the right-hand side, and think about service creation. Because those people that are creating services, whether that's internally inside the enterprise, whether it's externally within a cloud provider, they're making a number of assumptions. They're assuming that the network is always there. Mm-hmm. They're assuming that bandwidth is unlimited. And they're assuming that they can deploy that infrastructure immediately. And we see that. So I was talking to a customer last week, a large retailer, and they're using what we call what's increasingly being known as a DevOps mentality. They've created a self-service portal, mm-hmm. and that allows the developers who are obviously creating those services and bringing them to their internal users to stand up their own infrastructure. They make their own decisions about what should be in that catalogue of services. Mm-hmm. They build that into that portal and then consume them as they need them. And they're using open source tools like Puppet to create that automation so that they can do that. And there is a very large open source community who are collaborating, and the concept of open source, with the advent of Linux in the enterprise and the way that people are using that is an interesting one. Brocade, we technically lead the Open Daylight initiative, and Open Daylight is looking at bringing a lot of that collaboration together around those automation tools from a network perspective in the industry, so that we can start to produce some standards. The work that Red Hat, Canonical, Piston Cloud are doing to try and, in the way that the commercial versions of Linux have been brought to market, doing the same thing around automation tools.
How mature is that project then? If I was going to start looking at my automation, building my automation on top of that, is it practical?
Around the OpenStack initiative, massively mature. Massively mature. We see organisations using cloud service providers, but I'm talking here about the retailer as an enterprise customer. Mm-hmm. Okay, it's only in their development environment, but as they feel comfortable using that in their development environment, they will, and they've stated an intent to move that into production.
It raises an interesting point as well, and that's that the fear of lock-in applies, just as much in networking as it does anywhere else. You need to integrate with everything else that you have to work with.
Well, more so at the moment, because a lot of networking, a lot of what we're going to be doing next is a little bit up in the air, isn't it?
It's open, and it's open to debate, but there's the need for flexibility means that the networks have got to be, almost by definition, able to talk to lots of other things as well.
Yeah, I think what's inevitable will happen, I think, and I know that I think we all agreed on this outside, was what will happen is that there is a new orchestration or virtual layer that will come into networking. So some of the functions will be abstracted in the same way that it happened to the server world. The reality is, you would be a very, very, confident person to bet on which way that game's going to go, because it's way too early to tell. So what we're trying to do is almost play the abstraction game and say, make sure your infrastructure is set in an open environment now to support what's coming down the line. And that remains sticking, strongly to open standards, whether they're Trill-based, whether they're obviously the IEEE standards, and obviously the Open Daylight and the OpenStack standards we think are imperative for any organisation.
And it's a challenge for, people in the networking business to actually get that understanding of, what can you do today and how open are things.
Which is my question.
That's a big issue.
That's my question. But I mean, it's fine
it's
to
an
say
education.
that it's a challenge for them.
It's not open. VMware and Cisco has refused to support VXLAN from VMware. So it's made a statement. It's saying I am not going to play in software-defined networking with Cisco. That statement is made. So therefore, the world-leading networking company and the world-leading virtualization company are now in open competition. Now, who's going to win that battle? And I'm sure the people watching this will have some very strong views on that.
What do you think?
Well, I think that we're well positioned to see that battle, and then take the honest broker in the middle and go, you shouldn't really care about this battle at the top. You've got to make sure you've got an infrastructure which is suitable for VXLAN or Trill fine-grained labeling or whichever route that you want to deploy your software-defined networking or abstraction layer in the future. Make sure you go down it. You wouldn't buy a server. I don't think people would buy a compute block which didn't support multiple hypervisors. You wouldn't go to IBM and say, this only supports VMware. Well, I might want to go down a Microsoft route. Mm-hmm. So with your network, you've got to do the same. Now, the battle lines are getting drawn, and network is becoming very proprietary very quickly.
Should we be looking at, so time to deploy here is a problem, so we accept that. So should we be looking at should people have specific sort of task teams to say, okay, our time to deploy is this much, we need to bring it down to this, by this time, and we need to do it this way. Is that a realistic way of going about it?
We do it internally. We looked, we use Amazon Web Services for some of our proof of concepts and test developments because they can set up virtual machines quicker than we can due to our internal protocol rules. So I think that, we use benchmarking from external people as much as anything else, managed service providers, web service companies, Internet 2.0 companies, to see, what should our standard be. Now, as a private enterprise, you're always going to be slower because you have more constraints, You have specific applications, you have security issues, and you have a control issue. But they're the benchmark that you need to kind of measure against. And taking 3 or 4 weeks to build a virtual machine, which some organizations do, really is too long. So I think there does need to be a benchmarking, and I think, you should refer to maybe the Gartners or the IDCs of this world to give you some feedback on what that benchmarking should be. Or Freeform Dynamics.
I was going to say, yeah.
Sorry on that, Tony. Clearly
you physically recoiled.
Yes,
Tony.
Absolutely.
No, Tony, give us your view on this one then, because, we say, people should deploy quicker.
Well, no, the point is that
you're never going to be as quick as Amazon Web Services.
Quite often, the biggest inhibitor to actually deployment has got nothing whatsoever to do with the underlying IT technology. IT gets the blame, but it's that change management process that sits on top of it. And quite a lot of the input to change management doesn't come from IT. IT gets the blame, not always the cause of the delay. So that's why I brought up change management earlier, that as we move to a more dynamic environment, and it's something that's come up time and time again, we've got to change management. Not all changes will need the same amount of scrutiny. Some things you can just do, bang, okay, fine, we've got a process, off it goes. Other things you might want to stop and think a bit more about, whether it involves moving outside or significant application changes or significant networking changes where you think there might be a risk. But that means that your change management processes need some modification, and that means the business people have also got to get involved in that because, they are quite often a brake on change management. It's not just IT.
One of the, and we're going to come on to the subject of SDN, I can see it on the slide.
The elephant in the studio here, isn't it? Yes.
I was having a conversation with an architect in a large finance organisation some time ago, and we got onto the subject of SDN. And one thing that he could see in that organisation was the promise of SDN to bridge the gap between engineering and operations in those types of environments. That if you can visualise your infrastructure in a different way, then what gets designed by engineering and infrastructure teams in terms of what they'd like to see implemented versus what operations actually do and what gets put in and therefore what they have to troubleshoot is problematic. If you can set some policies around the way that things should work and then see those in action within your infrastructure, then it becomes very easy to ascertain what those changes are going to mean to the environment, and also to troubleshoot, because you can see the ways that things should work, rather than having to go through that discovery process before you begin to fix.
So, now we have broken open SDN. The basic question is this something that people should start acting on rather than just thinking about? Because it's pretty easy to read a white paper on SDN. There's a lot of them about. So do you start basing decisions on that?
I think you need to. I generally do. And people might think we're eating our own young a little bit of that, saying a hardware vendor talking about software-defined networking. Yeah. I think if we move to the next slide, Tim, it shows this in a pretty good way. This is an architecture that pretty much everyone agrees on. No one in the market sees an architecture differently. If we take the pink layer and above, the network controller, above to the business logic level, that's where software-defined networking plays. The point that we've got to get better at is educating and people understanding that the infrastructure required is still an infrastructure. Software runs on hardware and always will. So if people believe that software-defined networking is going to remove their hardware spend on networking, that's an incorrect assumption. What it's going to do is going to allow them to define the networking, as it states in its very name, a lot better, and have a much more better automated solution. This battle at the top of the network is going to be a difficult one to plan of who's going to win that. You have people like BMC as an automation company, you have VXLAN from VMware, you have Big Switch, you have Contrail, you have all sorts of players. You have IBM, which are moving into this market pretty aggressively, in fact with us, into that area. What we're saying is we're an infrastructure company. We want to make the correct infrastructures to support these orchestration systems going forward. And the biggest step to that is as you can see in the orange boxes, is virtualizing what you can. I think the advice today is really virtualize whatever function you can within the network. Ask yourself, if you're layer 4 to layer 7 switching, why are you using a separate hardware device to do that? Can you do that in a software way? Does that save you money? Because every piece of hardware you fail to put into a network center or data center saves, the impact is huge in cooling, power, et cetera, et cetera. And so what we're designing now is making sure that our physical infrastructure is kind of, the racehorse. I mean, we acquired Foundry Networks. We were known for making the fastest, densest kind of products in the market. And we're back to our heritage and making sure that we just provide the single best physical infrastructure you possibly can, and making sure we're aligned to allow this whole software-defined networking play to play out. And really, we are seeing people starting to make some pretty bold moves. And I think, VMware is the big disruptor, and I think that they will certainly change things. And what I can guarantee is the market share for networking will no longer be like, in 5 years, it won't look like it looks like now. I'm not saying that number one won't be number one anymore, but I'm saying there won't be number one with 80% market share. It will be significantly less because of the disruption this brings.
So in terms of, if I'm looking at purchasing and upgrading on the hardware side,
yeah.
Software defined, to make myself open to software defined networking as it evolves, then your hardware decisions don't necessarily have to change very much in what you're investing in.
Well, I think they do. I think you need to look at you've got to move away from what we call the hierarchical network design, core aggregation and edge, because that is based on client server topology from 20 years. We believe you need to look at what we call a self-forming, self-healing, fabric-based network, which means that you aren't predetermining the connections through that network, because the network will evolve. It becomes a living, breathing thing. It doesn't nail itself up like it does. Like the internet. The internet isn't a defined network. It changes its roots on a constant basis. And that's how we've designed all of our topologies, because that's how storage networking has always worked, in a self-healing, fabric-based system.
Mm-hmm. There's a term I hear being mentioned a lot in conjunction with SDN, and that's IP backplane. This concept that the network becomes this backplane that allows your data flows to move across it, so that they can move in any direction, and that you can also offer those different service levels. And I think one of the interesting promise and perhaps the way to think about SDN is that from this diagram is to say that it's bridging the gap between the applications and the network that sits underneath. So the panacea is that the network is able to handshake with the application, that the network is able to offer service levels, the application is able to request service levels, just to say, hey, I'm a financial transaction, I'm really worried about latency, but there's not going to be very much data, versus I'm a backup, I'm not actually worried about how fast it happens, but I'm going to send an awful lot of data. So and it makes it sound very simplistic, but that's the promise, and I think
we are talking about simplifying. I think we are talking about removing complexity, and the simplicity of that powerful argument. How practical is that today?
We have examples of practicalities now. I mean, for instance, with our own infrastructures, we can prioritize, NAS attached storage through the IP network above everything else under certain conditions and certain policies you set, and that's pretty important for people that are trying to tier their storage. Basically the rest of the market believes, well, the whole of the market except one believes that networks applications become network aware. The leader believes that the network become applications aware, and that's where the battlegrounds are actually drawn. But there's people now that are driving some basic software-defined networking concepts out there. The VXLAN gateway, which was only just recently launched, that's starting to really gain some momentum. We have several implementations across Europe where we're already doing that. And it's interesting that VMware have already admitted that they need a hardware controller, because they thought everything could be done in software. They need a network infrastructure controller for someone like us to get it to work.
This really comes back to that slide we had earlier about the movers and the dreamers and how they see things changing. Mm-hmm. The idea is very much to work out, well, what can you put in now that you can exploit more widely going forwards without limiting yourself in any way, so trying to avoid as much lock-in as possible. That's really the thing that the guys out there have got to get their heads around.
that's my argument completely, Tony. Because what I'm saying is, if you are, if you are a dreamer, or the people, the
pragmatists,
pragmatists, you are a pragmatist on this. Does your direction today preclude you being able to enter this world, which we've had, this very alluring world, but which which is not, again, is too much risk perhaps at the moment to commit too much to?
Not really. I mean, ours is all done at a software level. So the products that we make exist in the normal hierarchical environment. You then put something called VCS, virtual cluster switching, on top, and it allows you to have a fabric-based design. Mm-hmm. All I would advise people to do is really don't waste money on another cycle of hierarchical networking. If you're going to do the same thing again, that is a waste of money. Then you may as well just try and sweat that asset for as long as you can. But I believe that decisions can be made now, not only from us, from other players in the market, which don't push you down into an end.
The other thing is that this isn't just something for the really big data centers. Yeah. It's something for the computer rooms, or even people with just a rack or two to start thinking about, because it hasn't been thought about in most organisations without the networking specialists.
That's right. You see, my question is for this is as a sort of a proof of concept, a dipping a toe sort of thing. Is it possible to do that? Is it possible to just do something very, very small and limited?
Yeah, absolutely.
And to say,
yes.
See how it works?
Yes, it is, and at all scales as well. So
what would you do?
We have customers who are able to put in 2 switches in the top of a rack and create a fabric. And when they wheeled an X rack in, put 2 switches in the top of that and connect them up and grow and scale that fabric as they need to. We've got examples of where we're working both with enterprise customers and cloud service providers where they've specifically chosen this fabric architecture to move away from those forklift cycles, so that they know that they can grow and scale their network in any topology that they like, and that they benefit from the automation, the intelligence, the self-healing capabilities that also reduce those overheads at the same time. On the larger scale, we have customers who have chosen to deploy programmatic capabilities on a hardware, and so a network provider, for instance, was able to program flows in their network without disrupting the existing traffic. So they were able to do that in a production environment, and to automate some of those flows as they took on customers, which gave them a significant advantage over other organisations who were trying to do the same thing but manually.
Yeah, and I think the pragmatic step is we're normally starting these days at the top of rack position, which is either convergence or fabric at the top of rack, moving a layer from the network. So instead of having a 3-tiered network, the most pragmatic approach is your aggregation layer and your core layer you can condense, or you can even condense your edge and your aggregation layer into a single layer. The second thing that we see people doing more and more often is actually then considering convergence, because something we didn't talk today is convergence, where combining your storage and your IP networks together as well. So there are 2 pragmatic things you can kind of do day one. And what I say to people is use proof of concepts. All the vendors out there will do proof of concepts. We will. I know that our competition will, and we find them, highly enlightening to people. And we like the challenge to be put into a proof of concept environment at our expense and see if this stuff that we talk about all the time works.
If you're still in the business, Tony, what would you be doing today?
I'll be desperately trying to find some time to actually sit down and work out what is out there, what can I do.
Yeah.
More importantly, as we've touched on time after time, I'd be trying to find the time to actually work out, well, what am I doing now and why am I doing it? So that I can begin to look at these service levels and the business requirements. How flexible do I need to be? For which bits can I start first? And it's just finding that time, particularly for smaller businesses, to work that out, because the networking hasn't been top of mind, but it needs to get much closer than it has been in the past.
If you don't create a sort of specific project, if you don't carve out some time for this, you're just going to carry on.
If you're in a smaller business, then you're going to keep on doing what you've always been doing until it breaks.
Yeah.
And so if you can find some time just to begin looking at it, it's a chance.
But the point of this is evolution. So there's nothing that the audience won't understand about where this has come from.
I'd say it's not evolution, because evolution means making lots of random changes, some of which will be beneficial, some of which will be absolutely disastrous.
Don't do it that way.
May be the way I did IT, but it's not one I'd recommend.
No. But it's the idea is, the idea we've got is these sort of sort of big picture goals that that we're looking at. So the scalability and reliability and things like that. They're the same as they've always been. But what we're saying is the implications for your actions and straight underneath they've changed.
The idea now is that you can get away from networking. That's basically just a bunch of fixed points that go up and then come back down again.
Yeah.
So that if you want to get from here over to there, you've got to go all the way up and come back down again. Put in something more like a street plan, where you've got lots of different streets you can get between.
Well, I think even simpler than that, what we're saying is, in old network designs, you had to think about the paths that it would take. You had to think about how is this traffic flow going to roughly look. You looked at VLANs, domains, and all kinds of things. Now what we're saying is, you don't really need to care. You're going to build a self-healing, self-forming fabric which takes care of the traffic flow. Because the reality is, as soon as you virtualize, you have no control of that traffic flow. And anyone that thinks they can control a traffic flow, within a virtual environment, it's very difficult. You can contain it, but you cannot control it.
And put yourself in a position where you're actually confident that the automation and that it does work. And that, I think, is possibly the biggest thing. Get some trust that it works.
Yes. Final question is to Julian. What happens if I haven't got the skills in my organisation? We were saying skills were a constraint. We're going to need new skills for this, are we not?
Not necessarily. Not necessarily. What we find is that and certainly I can speak from our own standpoint, that we have customers today implementing infrastructure alongside their existing cores. They're interoperating, even down to the point where the command line is very similar. I also think, as Tony alluded to, the automation tools are important as they begin to work. That people will configure and work with the network in very different ways. To build an Ethernet fabric takes a couple of commands on each switch, and you deploy it, you plug them together, and it learns. So we have a lot of success with that, and our customers learning to work with that technology very quickly. And Tim, it's no different to what people have already done with those waves of other waves of disruption that we've seen: storage consolidation, server virtualization, desktop virtualization. Those concepts around virtualization have all been done for the same reasons, around inflexibility, around overcapacity and undercapacity in different places. And we've fixed those by introducing virtualization. And I think people will be familiar with that. And as you begin to apply those concepts to the network, it's no different.
The only difference here is how to make the business case.
All right.
Because the others were really obvious. This one you've got to put a bit more thought into.
I get it. All right, we're out of time, I'm afraid. Thank you very much. Thank you for all your help. Let us know how you get on with that. There's quite a lot to do. But we hope we've given you an idea of what the first steps would be. Don't forget to let us know what you thought of this at the Reg. We do more of what you like, less of what you don't like. So tell us, and we'll do it. As you can see, we've got our further reading slide there. There's quite a lot there as well. So here's a really good start. Take a couple of hours and have a look at that stuff, see if it tells you anything. Thank you very much from the team, from myself, Tim Phillips, from the Reg. Goodbye.